All right. Hey, everybody. Happy Thursday. Today's your in-between day, in between your Wednesday assessment, and then Friday you finish up the assessment. Anyways, you got a full 2 periods for that. So we're still in our systems of linear equations and linear inequalities unit. And one of the things that's kept coming up by when I ask you, I prompt you, and it's very helpful for me to actually write this out and to read this, is a lot of times I ask you, what's one thing you might want to know a little bit more about or practice? And so many people, multiple people, last time I asked you that, maybe around 5 people or so, wrote, I want to practice the elimination method more. I want to learn how to solve systems by elimination. And I think part of the reason why you want to do that is because elimination oftentimes can be the easiest way to solve a system of equations. You just got to get practice. Got to see the right situations to use elimination. And that's where we begin now. So we have here question 466. It's right down here. Today's lesson is more elimination. You're going to do 466 to 470, page 170. We'll do all work right above me right here. But this first question here, 466, is actually going to allow you to really think about when, right, what situation would it be a good situation, a good candidate to use the elimination method here. Okay, so you're welcome to read this up here on top all by yourself. No, not really any reason why we need to read it together. We're just going to do the same thing with systems, creating one equation with only one variable, eliminating one variable. How do we know the solution is correct? And it's just kind of like a little bit more complex elimination stuff we've done is actually me in this section here, okay? Because you guys are a bit above where this section kind of thinks you are right now. So anyways, let's take a look at this here. All right, 466 here. So we want to get down to this. I already told you this question had to do with which is a good situation to use elimination, because you only have to do one of these problems, okay? So do either, right? Do either A or B. You get a choice, right? You get a choice, right? Because about math, part of math is like choosing the right pathway that allows you to go faster and working more efficiently. And that's sort of what this question is about here. 466, which system of equations would be easiest to solve using the elimination method? Once you've explained your decision, use the elimination method to solve this system of equations. You do not need to solve the other system. Record your steps and check back your solution. Just because I'm a teacher, I'm going to copy them both down. So here we got this. What am I noticing as I'm copying down? Well, it's not written in y equals mx plus b form. That's a little hint there. It's written in a different form. You probably already have answered this right now. You're like, Mr. Ford, you don't need to do all this. I got the answer, but we may need to look at it. That might be part of the reason why you're watching this video here. Okay, this isn't in y. This actually is in y. Look, y equals mx plus b form. Ooh, is that good for elimination? I don't know. So anyways, let's see here. Which one's the easier to solve? Well, here, if I notice elimination, that's the one where you add the equations together. Here, yeah, if I add the equation 1 to equation 2 right here, my y's are going to cancel out because negative 4y plus 4y, right? Well, negative 4 plus 4 brings us to 0. That would be 0y, right? That would eliminate y. That'd be good to go. And then here, this is all good. Another thing, a big important thing to notice here is that the equal signs also are right on top of one another. So maybe I'll change colors for a second so you can maybe see what I'm talking about here. But the equal signs are right on top of one another. So here, we'd be able to add this left side of the equation to this left side of the equation. It's just going to eliminate the y's. Right sides together, and then we'll just have ones over here. That's nice. We'll have our x's over there. So this is totally the one that I go with elimination right here. This one here, this one's not that good of a candidate. So they do have the equal signs lines right on top of one another. The problem is, though, check this out. So the problem that they really want, the thing you should look out for is this, which is that, right, the y's, okay, right, the y variable are on opposite sides of equals, okay? So that's a little note to yourself. Put that down as a note, right? You'll remember it if you put it down as a note. You might have to read it again if you put it down as a note, but you'll remember it. When y variables are on opposite side of equals, it's not, right? Not a good candidate for elimination. Right? When you got variables you're trying to eliminate and they're just on opposite sides, no, you can't really do that, right? We'd have the lefts here, we'd have x and y on this side, we'd still have y on the right side here. Not good, not really eliminated here. So this top one here is sort of set up for substitution, right? Part B is set up for substitution. We already have y isolated. The way I would solve this is I would replace y with 4 minus 2x, 3 times 4 minus 2x, and then distribute 3, and then add the x. So it can be done, but I'd be doing it during substitution. Okay, so that being said, what we're going to do in the first one, because you only have, remember, you don't have to do one of these using the elimination method, is we're going to do A together. Okay, so we'll do A together, And yeah, if you're watching this as a lesson, you want more elimination practice, perhaps you just want to do problems with me. That's fine too. 5x minus 8x, well, we're taking away 8 from 5, right? Taking away 8 from 5, so our results, our sum is going to be negative. So we get negative 3x. Negative 4 plus 4 would be 0, right? Negative 4, and that's added an inverse there, brings me to 0. So that's where the elimination is. Those just eliminate right there. I don't even need to write y again. 0y just means 0. 0 times anything is 0. Okay, so now I got this. I got 37 minus 52. So 52 is a larger absolute value than 37. So since that's negative, my sum is going to be negative here, and they're 15 apart. Do that in my head. I'll also use a calculator too, right? Use a calculator, okay? There we go, okay? So this is what we did. We got this down, elimination. Now we got negative 3x. So this simplifies here. This simplifies to negative 3x equals negative 15. And that's good, because that means we eliminated one variable. We've created one equation with only one variable, and that's nice. So now we can go through and use our solving steps, which again, we don't review these solving steps a ton in Algebra 1, even less this year. So please check in with me if you're having trouble solving equations. If we have x, we got our goal here. If we get x by itself on one side of equals, we've done our jobs. Here we got negative 3, but it's being multiplied times the x right now, okay? So to undo things, to simplify this down to x, you need to do the opposite of what's happening to x. What's happening to x? Negative 3 is being multiplied to x. What's the opposite of multiplying? Dividing. So we divide both sides by negative 3, and that's going to cancel out the negative 3 that's being times by x. If we just divide by negative 3, that's an inverse operation. That simplifies down to x. And then over here, negative 15 divided by negative 3. Again, get your calculators out, right? Not like you always want your calculator on your table when you're doing math homework. Move through it. Negative 5 divided by negative 3, and you can do it in your head, great, but like, save the brain space for actually the things you need to think about. You don't really need to think about a problem like this, okay? So negative 15 divided by negative 3. Well, 15 divided by 3, you got to know your multiplication tables at this point. Absolutely do. If not, study them. 5 divided by 3 is 5, and then they're both negative, so the divide two negatives, you end up with a positive, okay? So just reminders on that there of some things that may trip with some people up, okay? So we get x equals 3. That's not the solution to the system, though, because, again, they're asking solve using the elimination method, okay? So once you've explained your decision, I didn't really do that out. Maybe we can explain afterwards. To solve the system, we need more than just x, okay? We need x is equal to 5. We need to figure out what y is, okay? So we'll go back to this top equation right here. 5 times by, instead of writing x, I'm going to write 5, okay? So I'm going to use this top equation to determine what y needs to be. And yeah, then I'll get my XY coordinate. It's called a coordinate pair, right? Where those two lines intersect, it'll be a coordinate pair, an XY coordinate pair here, okay? So 5 times 5 is 25, minus 4y is equal to 37. Here's what I'm going to do. I'm going to move my 1's to the left side and my y's to the right side, right? See, this is negative 4y. I'm actually going to add that 4y to both sides. Quick tip there. If you have a negative, if the variable's negative, then just add it to the other side and boom. Voila, it's positive, okay? Got to get rid of that 37, so I'm going to subtract 37. So notice here I'm doing this through one side. If I'm doing something to one side of an equation, I'm going to do the same thing to the other side of the equation. So I'm going to take away 37 here. Those will cancel. Remember, I'm adding that 4y. I'm adding that 4y. That canceled. And I'm taking away 37, so I'll take away 37 over here. If I'm lowering one side by 37, I lower the other side by 37. And then the equation is still true. And they're true because they're given to us at the beginning. We're just modifying it using the rules of math here. Okay, so 25 minus 37 is negative 12, and that's going to equal 4y. That means y is going to equal negative 3, right? Because what I did there is I divided both sides by 4, right? Remember, the number right in front of the variable, divide by it. And then negative 12 divided by 4, divide both sides by that, and you get negative 3 for y. Okay, so there's my answer. Answer to this one, right, as a coordinate pair. Remember, coordinate pairs are x comma y, and that'd be 5, negative 3 is my answer there. Hopefully I did that right. Hopefully I got the right answer. But of course I could check it in my head here. Okay, so you're supposed to explain, right, which one we chose. Like we chose A. Okay, we chose A for elimination. And what do we do there? Why did we do that? Well, all x's and y's were on the left side of the equals. Okay, all that left. Okay, so all x and y, those are called terms, right? Terms. We haven't really talked about terms yet, but 5x is a term, negative 4y is a term, 4y is a term, negative 8x is a term. The things that are separated by pluses or minuses in these algebraic equations are called terms. All x and y terms are on the left or same, right? Left side of equals, okay? Simply add and y will be eliminated. Or I'll just write eliminate right there. Okay, so that's why we chose this. So I should hopefully hear some justification for it here. What's the more simple way than saying I got all my x's and y's on the left side of equals? Well, these are written in what form? That's a quicker way you could have written this. Okay, we chose to all x and y terms are on the left side of equals, and that is the, drum roll please, that is the standard form. So you could have said that when you're just describing why you chose that we chose these ones here. These are written in standard form. Standard form is a great, right? If they're both written in standard form, perfect. Try to add them together. Maybe a variable eliminates. Otherwise, you might have to multiply one of those equations. These are in standard form, right? If they're in standard form, great candidate for elimination, okay? So standard form just means a coefficient multiplied to a variable. So 5 is the coefficient there, multiplies to the variable, plus another coefficient, -4 times y times the other variable is equal to a constant, which is a number down here, okay? So I think actually they remind you here, yeah, what a standard form is written like this. Slope-intercept form, we've talked about a bunch, right? Y equals mx plus b. If you know what the slope is, you know where the y-intercept is, you can write the equation in y equals mx plus b form. Standard form just like cleanly writing it out like with x's and y's on one side of the equation. There's this other thing they write about at the very end here, which is barely in the textbook, but something worth knowing for geometry and algebra 2, you'll be going over this here, something called point slope form, which we're not going to bother with point slope form this year. Definitely not. I usually talk about a little bit in algebra 1, but let's not worry about point slope form. All right, let's do this. So we've answered this. A plus answer 466. Very good. Let's keep on going, guys. Shall we? Shall we? Let's do it. Let's do it. Let's do it. And yeah, you know, like I film these videos to go kind of slowly through them with you because, you know, if you need the help, if you're looking to get the help, you don't want some guy just going super quick. And so maybe some of that was quick. Maybe what I just did was quick. Rewatch it, pause it, send me questions. Okay, so these videos can't be 2 hours long. We want it to be like, I don't know, tops 40 minutes, that kind of thing here. So keep it kind of here. But if you need the 2 hours things, right, come to office hours, ask questions, other stuff like that. All right, anyways, we got Rachel. Rachel's over here, and she is trying to solve this system. 2x plus y is equal to 10. So I'm going to copy down because it says combine these equations, see what happens. So remember what I told you a little bit earlier is that this lesson, they think you're not as far as you are, right? We're at the end of our unit. We've kind of seen a lot of our stuff here. We practiced a lot of stuff here. So at this point in the textbook here, right, where this lesson falls, you haven't multiplied equations at all, okay? So that's something that came up kind of quickly, right? We're trying to cover some ground kind of quickly in our normal day-to-day classes. So here, when it says combine equations, they mean just add them together. Because the last time you did group work, all you had to do was either add the equations together or subtract them from one another, right? Multiply them by -1, and then something would eliminate. Here, if we try to combine these equations, right, what they mean is, well, what happens if you just try to eliminate right away, right? We add the left side to here and add the right side to here, right? We get 11 over here. That's not a problem. But over here, we would get 5x, and then y minus 2y is -y. And we'd end up with another equation. This would be true, right? This would totally be true. This would go through the common intersection of these two lines right here. But the problem is we still don't get any help in figuring out where the intersection is because we still have y. Okay, we still have x and y. Okay, nothing eliminated here. So that's sort of our answer here. Right? Our issue with this, with combining them, is that what happens, and if we just added them together, then neither x nor y got eliminated. So we still have a true statement, eliminated. So we still have a true statement, right? 5x minus y equals 11 would go through. That was from your lesson when elimination got introduced. If you create a combined equation or an equivalent equation, it's still going to go through that common intersection of equation 1 and equation 2 where they would intersect. Like, it would still go through that. But, you know, hopefully you get a horizontal line or a vertical line, right? Because that would only have one variable in it. That would allow you to solve for the variable, one of the coordinates of the intersection. So this isn't going to do that. This is a diagonal line, right? We know that because we have x and y in there. We don't just have one of the two, right? X equals 5, y equals 10, right? That would either be a vertical or horizontal line, respectively. So anyways, neither x nor y got eliminated when we tried to combine. So that's our answer to A here. Keeping going through it, right? Rewatch things if I'm going too fast, but I do want to go through this stuff here in case you're just like, all right, move on. I want to go to the next thing. So let's check this one out. 2x plus y equals 10. Is that the same line as 4x plus 2y equals 20? Let's inspect here. What's happening? 2x times 2 is what? 2x times 2. Let's maybe see here. So let's try to check this out. If I'm actually 2x times 2 would bring us to 4x. Okay. That would bring us to 4x. 2 times by y. Okay, 2. Remember that we have parentheses here. We got to distribute. So multiply the right side by 2. 2 times 2x is 4x. 2 times y is 2y. So I'm going to do plus 2y here. And then 2 times 10 equals 20. And that's what we have here. 4x plus 2y equals 20. So yes, right, if I just multiply both sides of that equation, 2x plus y equals 10, I get 4x plus 2y equals 20. So this is the same line, right? This is the same line here. These are equivalent equations, okay? Let's see here. They're the same line. Yes! They have the same solutions. Simply because they are equivalent equations. And that's a claim, right? That's a claim that I'm saying that they're equivalent equations. So my justification for that is that 4x plus 2y equals 20 is simply 2x plus y equals 20 multiplied on both sides, right? We multiplied both sides by 2. Okay, by 2. And we're allowed to do that. Remember, if we have a statement here like that we know is true, 2x plus y equals 10, and then we double the 10 side to become 2, right? We multiply the 10 times 2, right? And they were equal to begin with. Multiply that by 2, it becomes 20. And I would just have to multiply 2x plus y by 2 to maintain that equality. So 4x plus 2y is definitely equal to 20 based on something called the multiplication property of equality, which you guys in geometry have studied a little bit here. So yes for that one. We'll go to C here. Since you can rewrite 2x plus y equals 10 as 4x plus y equals 2y equals 20, okay, we discussed this as a class. We've kind of gone through it. Perhaps the equivalent form of the original equation can help us solve this system. Combine 2x plus 2y equals 20. So anyways, yeah. So they're just saying here, the original thing, why didn't we just change this, right? Why don't we just change this, right, to 4x plus 2y equals 20? And I agree, that's going to eliminate. Look at that there. 4x plus 3x is 7x. 2y minus 2y is 0, and then 21 over here. So let's just move it all down so we can actually do part C entirely here. So let's see if this combines here. 4x, so this, remember, we're taking 2x plus y equals 10, our original equation we have here. In disguise, we multiplied it by 2. We get that equals to 20, and then we're going to get the other one, 3x minus 2y equals to 1, right? And that's the original equation there. Nothing changed there. We know it's going to be the same, so there's nothing changed. 4x plus 3x is 7x. 2y minus 2y, there's where your things eliminate right there. And then 20 plus 1 is 21. And look at that. We got one equation, one variable. And what can we say? Well, 7 times 3 is 21, right? So x has got to equal 3, right? X has got to equal 3. Another way to get there, divide both sides by 7. Divide both sides by 7. So 7 divided by 7 is 1. That gives us 1x. 21 divided by 7. Got to know your multiplication tables. If not, right, get your calculators going. Go real fast. Don't get left in the dust here. 21 divided by 7 is 3. Okay, so we get x equals 3. And then it says solve the system for x and y. So I got one equation, one variable. I want to get the other variable here. So let's go to that 3x1. 3 times 3 I'm going to write. I'm not going to write x. I'm going to write the 3. And maybe I'll show you that, right? I took this x equals 3, replaced it on there where I saw x right here, right? Replaced. And then I'm going to write the rest of this. Minus 2y is equal to 1. And this is going to become 9 minus 2y equal to 1. Pro tip here, I got a negative for my my variable appears. So I'm just going to add that to the other side. Then I'm going to make it positive. That's going to be nice here. Add my 2y to that side. I'm going to take away the 1 too. So I'm going to have my y's over here. I have my numbers over here to sort of simplify this. 9 minus 1 is 8. And then I got 2y over here. So if 2y represents 8, then 1y's got to be 4, right? Got to be 4 here. I can divide both sides by 4. just to be certain. But 8 divided by 4, yep, that's 2. And we got y equals 2 here. Okay, so my solution, right, solution to this system is going to be x equals 3 and y equals 2. And hopefully I didn't make a mistake with that. Sometimes with these videos, because I'm talking so much, I'm going through some stuff, I don't go back and check my answers, right? I'm not looking at the answer key right now. So if I make a mistake, please let me know. But hopefully I at least laid things out here where we can get you thinking about it and get you understanding how to do this. Okay, why was the top equation changed? Would a variable have been eliminated if the bottom equation were multiplied by 2 on both sides here? Okay, top equation, right? Top equation was multiplied by 2. It's just having us reiterate what we did here. Again, processing, right? Processing, working out the kinks in your brain about why we're doing this. What are we doing here? It requires practice. Okay, top equation needed to be multiplied by 2 so that the, what was it, the y's or what got eliminated here? So that the y terms eliminated, right? The y terms, okay, right? So like 2y got eliminated by negative 2y. Those are terms, right? 2y and negative 2y are terms. The y terms, so the y terms got eliminated. Okay, and then let's test out what they're saying here is what if the bottom equation, right? This one here, we're multiplied by 2. Is that going to eliminate here? And no, it looks like it's not. I mean, if you got this one here, 2x plus y equals 10, multiply the bottom one by 2, 6x minus 4y. This is just silly. And then this is 2 here. This isn't going to eliminate, okay? So the thing you multiply by before you try elimination, super important, okay? So hopefully you've gotten there. Hopefully you realized why the top one, multiplying by 2, was important. Because 2y is the opposite of negative 2y. Those are additive inverses. That's the reason why I do. There's no reason to multiply the bottom one by 2. I mean, you could have multiplied the bottom one by half. That could have worked. But bottom one multiplying it by 2, this isn't going to eliminate, right? Because we got 8x here, and now we have negative 3y is equal to 12, and no, right? Right? We got an x and a y there. It doesn't work, okay? Right? It doesn't eliminate if we just multiply the bottom one by 2. Okay, so hopefully you're being strategic by what you're multiplying by as you guys are doing elimination here, okay? So let's keep going down here. What does it say here? 468. Let's do 468 right now. It says, for each system below, determine is this system a good candidate for the elimination method? Why or why not? What is the best way to get one equation with one variable? Carry out your plan and solve for the system for both variables. Is your solution correct? Verify by substituting your solution into the original equations. Okay, so we gotta basically solve these things if they're if it's good for the elimination variable. So let's determine this one here. So we got A. Okay, so let's maybe inspect this. We'll go through each bullet point together. 5m plus 2n equal to negative 10. And 3m plus 2n equal to negative 2. And what I would say, top bullet point is I would say good for elimination. Why am I saying that? Why is this good for elimination? Don't zone out. Don't go away. This is get your brains going in math class here, okay? Why is this great for elimination? Well, all the variables are on one side of the equal sign. They're all on the left side, right? On the left side. It's all set up for elimination. It's written in standard form. Okay, so right, that's good for elimination, okay, because they're written in standard form, okay? There's my justification for that. Nothing else has to be said there. It's written in standard form. It's good, and the best way to get one equation with one variable, okay, is what we're going to do is it looks like we're going to have to, well, we can't just add everything together, okay? So what we're going to do is we're going to multiply. Bottom equation. Let's do bottom. Maybe I'll do top equation. Equation by negative 1. Okay, that's what I'm going to do. I'm going to do it by negative 1. And I chose the top one here because negative 10 is a big negative number. Let's make that one positive. Let's make it positive 10. That's why I did it here as kind of a heads up. So let's just maybe change my color so you can see me eliminate here why I'm doing this here. Okay, I'm going to multiply this top one by negative 1. Why did I do that? Let's check it out here. See if you can figure out why I did that here. Why am I going to multiply this one by negative 1? Well, I got my 2's. The thing that's shown out to you here is 2n plus 2n is 4n, and that doesn't cancel out. But remember, we're looking for opposite coefficients. So if I multiply negative 1 times by positive 2, that gives me a negative 2. Okay, I'm going to move this down here. This purple stuff I'm doing here, I'm going to move it down here because then I'm going to be able to add the equations together. It's going to eliminate right away. It will, trust me. Okay, so if I multiply my left side by -1, I got to multiply my right side by -1. Let me finish doing the left side here. -1, because this distributive is called the distributive property of multiplication over addition, right? You should have maybe studied that before. -1 times by 5m is -5m. So here I got -5m minus 2n instead of +5m. Plus 2n, okay? We're just making everything negative on top. This is negative already. We need to make it positive, right? Because we're multiplying the left side by -1. Let's multiply the right side by -1. So this negative actually becomes a positive. Two negatives multiplied together become a positive, okay? So I get +10 here, and now it's set up where I can eliminate. Check this out. I can do that. I changed my top equation, wrote it down here. Now I got my basically equation 1, equation 2. Now I have a third new equation that would also go through the common intersection of the two. Remember that, it's just a new line that we know is going to have a shared common point here with these top two here. So we're going to use that to eliminate here. 2n minus 2n, there's my elimination right there, right? That's why I chose that. 3m minus 5m is -2m. -2 plus 10 is equal to 8. Oops, I got my negative right there. That's no good. Divide both sides by -2. So my answer is going to end up being negative for m right now. So I was trying to avoid the negatives by doing this here, but I couldn't really avoid them. Okay, m equals -4. Okay, I got that. Now I need to, it says, what does it say? Carry out your plan to solve the system for both variables. I got m, so I got to get n now. So let's do n. Let's do 5 times by -4 plus 2 times by n. Oops, solving for n now. It's equal to -10. This is -20 plus 2n equal to -10. These systems problems, good for practice. Good for practice solving, right? Add 20 to both sides. Okay, add 20 to both sides. I get 2n equal to 10. And I got n equals to 5. Okay, I'm going a little bit faster right now because this video is going on a little bit long here. So make sure you follow my logic with solving that. You should all be able to know how to solve something like that. Let's get more practice. We need more practice though. Okay, so I got n equals to 5 and m is equal to -4. There's no x and y in this problem, so I'm not going to write my answer as a coordinate. Maybe I'll do that here. Right, solution is m equals -4 and n equals 5. So maybe I'll write it in the same place, make it easy for somebody to pick out that we did it right here. Okay, is the solution correct? Verify. So I don't have to explain anything, which is nice, but it looks like here we need to verify that these are the correct answers here. Okay, so I'm gonna do that. I'm gonna plug back in to verify that I'm correct. Maybe I won't have to do that in B and C because it requires a decent amount of work here to do that. So that's kind of annoying. Okay, so 5 times by okay, hide that. I don't know why that came up. 5 times by m is -4 plus 2. Please stay with me, right? Please, just, especially if you're really watching this video at this point, I think you need it, right? Try to stay with me. Okay, so we'll try to see if that works. We'll try to see the other equation, right? If the solution's m is -4 and n is 5, if that works here. Okay, plus 2 times by 5 equals 2. All right, so let's check it out. Does this actually work? Let's see. Does that? Oh, there's actually true statements here. Here we go. -20, moment of truth. 2 times 5 is 10. Is that equal to 10? Ooh, I made a mistake. Shoot. Yeah, it doesn't work. What did I do wrong here? Oh, this should have been -10. I copied it down wrong. It works though. -10, 20 plus 10 equals -10. So -10 equals -10. So yeah, that works, right? The solution is -4 and 5 works in the top equation, and it's going to be another point on the other line, right? It's going to work out too. This is going to be -12 plus 10. Does that bring me? Oops, I missed the negative again. It should have been -2 right there. Look at -2. Does that bring me -2? And it does, right? -12 plus 10 is -2. And that equals -2, and we're good to go. We've checked our answer. All right, let's do B. Because if you're watching this video, you just want to practice here. So let's just do it quickly, right? First one I do is very slow. Then I do a little bit faster. Maybe you do one, okay? So then we got B plus 4A equal to 17. So I got this. Let's see. This is good for elimination. I can actually just add them together. Look, I could actually maybe rewrite this to make it a little bit more clearly. 6A minus B is equal to 3. And I can do this. I can change these. You can actually change these. This is something called the commutative property of addition, where if you're just adding things, order doesn't matter, right? Order doesn't matter, okay? I can switch these, and what that does is that's going to align my A's above my A's A terms above my one another and my B terms above one another. So I'm going to add plus B. And there's going to be 17 there. Okay, so this is actually good to go to eliminate here. Negative B plus B, those cancel out. 6A plus 4A, there's 10A. 3 plus 17, 20. Okay, divide by 10, A equals 2. Okay, I got A equals 2, and where's my other answer here? Okay, my other answer is going to be, we're going to get for B, so I'm going to use this one for B right here. Might as well use that one, B plus 4A, so B plus 4 times 2 equal to 17. B plus 8, that equals 17. Subtract both sides by 8, right? If B, you got to add 8 to it, brings us to 17. B's got to be 9 there, right? But I can just subtract 8 from both sides. 17 minus 8, that's 9. And B equals 9. So there are my answers right there. So my solution is A equals 2 and B equals 9. Okay, one thing we didn't do is we didn't go through that checklist, or we didn't go through this ahead of time, okay? But this one here was certainly good for elimination. Okay, good for elimination because why? It's written in standard form because each equation is written in standard form, right? A and B are both on the left side of the equation, right? We got a number on the right side of the equation, which we're good to go, like a constant number, not a variable number, written in standard form, okay? So it's good for elimination. And what was the second thing we need to do? Oh, what do we do? Well, I just rearrange where my terms were, okay? So just use the commutative property, right? Commutative, right? Commutes, move, commutative property to rearrange, okay? To rearrange and put, right? Put the things that are eliminating right above one another. And then we're good to go, right? I recommend that. All right, continuing onward, guys. Because here, you're watching this video, you just want to see examples, and that's good. You just want to hang out with good old Mr. Ford, and that's fine too as well. Let's check out here if we can do this next one. I might not do the recap, but is this good for elimination? Yes, it is. Because what form is it written in? This one's definitely in standard form. Yeah, this one's definitely in standard form. We can see because we have x and y too. We'll be able to write our answer as coordinates. It's written this, ax plus by equal to c, right? C is a constant. C is just a number, no variable here. So yeah, ax plus by equals c. Ax plus by equals c. Boom, perfect. Good to go for elimination. We just might have to multiply or something. We might have to find an equivalent equation to be the ones that's going to help us eliminate here, okay? Step one with elimination, see if you can just add the two together. Okay, see if you can just add the two together. So let's get it over here, see if we can add the two together. I got 3x minus 2y equal to negative 15. Step one with elimination, see if you can add them together. No, I can't add these two together. This is going to be 10x, this is going to be 2y, and this is going to be 2, and that doesn't matter over there. But 2y and 10x, we don't eliminate a variable. So step one, figure out if you can just add them together. And then if you can't, what are you going to do? Multiply equations together. Multiply not equations together, but just multiply an equation by something that will allow you to eliminate. So here, I got 3 and 7, right? If I multiply 3 by 2, it's going to give me a 6. By 3, it's going to give me a 9. That's not 7. That's not very good. What about this here? I'm going to look to my lower numbers. Maybe look to your lower numbers and see what you can multiply it by to equal one of the higher numbers here. This is negative 2, so I multiply this by 2. Okay, so if I multiply this by 2, and maybe I'll change my color here so you can kind of see it, multiply the bottom one by 2, and that's going to allow me to eliminate. It is. Check it out here. So that's going to move this. We'll do this down here. 2 times 3x is 6x. 2 times negative 2y is negative 4y. And 2 times negative 15 is negative 30. Okay, and that's going to eliminate here. I'm going to move my equation number 1 down here just so we can see it a little bit more clearly. Okay, I found an equivalent equation of this top one. Now I'm going to add them together because I know what the result is going to go through that common intersection. So this is going to be negative 30, and then I got to move my 17 one there. Okay, so I moved this one down here. Okay, so rewrote this one by multiplying both sides by 2. Just move this one down here, and now this is going to eliminate. Negative 4y plus 4y, gone. 6x plus 7x, 13x. And that's equal to negative 30 plus 17. Oh, I was worried it was going to be an ugly number, but it's not, because if we're adding 17 to negative 30, that's going to be negative 13. And that's not bad because I'm dividing both sides by 13. Negative 13 divided by 13. Well, 13 divided by 13 is 1. So we just got to make it negative. It will be negative 1 here for our value for x. Okay, so that's nice. Let's get our value for y. I'm going to use 3x minus 2y is equal to negative 15. So I'm going to do 3 times by negative 1 minus 2y is equal to negative 15. And here, this is negative 3 minus 2y. I did it again. I got this negative 2y thing. I might as well move that to the other side and make it positive. Okay, add this 15 to that side. Add this 15 here. Okay, negative 3 plus 15 is going to bring me to 12. I'm going through this a lot faster now, like a lot faster because we're late in the video, right? Late in the video, so perhaps you're just watching this on your own, trying to be like, okay, I just need to get it done. Just need to see a few more examples. So hopefully you're following what I'm doing here. Negative 2y. I'm going to flip that to the other side, but make it positive, okay? Because what I'm doing here is I'm really just adding 2y to both sides of the equation, right? 0 plus 2y is 2y. Negative 2y plus 2y, gone. Okay, and then now I got 2y is equal to 12. So what times 2 brings you to 12? Well, 6. But you can just divide both sides by 2 if you prefer to be really structured with the solving there. Okay, so I got x equals 1, negative 1, and y equals 6. So my solution is x equals negative 1, 6, right? X comma y, x comma y, x comma y. It's how you write a coordinate pair with x and y variables, coordinates. Negative 1, 6 is your solution. That's where those two lines are going to cross. What is that? Quadrant 2. Lots going on. There's a lot to keep track of with math here. So you're picking up new stuff every day. Just trying to do your best here. All right, we got 2 more problems, my friends. Woo! It's a long lesson. A lot longer. I meet somebody at 2:10 too, so I got to wrap things up here. I got 469. Anyways, you guys can't laugh at stuff like that in person this year, like you normally laugh at it. Normally you're here. Be honest here. All right, check it out. Tracy's team was given the following system by their teacher: 10x plus 4y equal to negative 8. There we go. And then we also got 5x plus 2y equal to 10. Combine these equations and then solve what happens. So let's just not add them together. We're going to actually just try to solve this, because if we just combine right now, x's aren't going to eliminate, y's aren't going to eliminate. So we need to figure out what to do. Okay. So this is my tip here, right? This is the first time I'm giving this recommendation here. Look to your smallest term, right? What is the lowest value? 10, 4, 5, 2. Okay, we're looking at that 2. We got 2y here. How can we use that in conjunction with this 4y to cancel out that 4y? What do we need to change 2y to? Well, we need to change it to negative 4y. What's going to take to get there? Multiply both sides by negative 2. That's it. We need to bring that 2 from 2y to negative 4y to eliminate that 4y. That's what we're going to do here, okay? So hopefully you follow that logic. Again, I'm just trying to get through a lot of examples quickly so you can kind of see it and try to apply it. And it'll come to you, right, if you keep practicing. Negative 2 times 5x is negative 10x. Negative 2 plus 2y is negative 4y. And that equals to negative 2 times 10 is negative 20. And now we can eliminate. I'll bring this one down here, okay, because I just brought this one right here. But this one we don't need to change at all, right? We can just multiply it by 1 if we want to. If we're pretending we're multiplying that one. Because sometimes you have to multiply both equations. Put it that way. Think about a little preview of 470. All right, and then that's going to be equal to negative 8. So now it's all ready to eliminate, okay? It's all ready to eliminate here. Negative 10x, plus 10x. Because remember, we're trying to eliminate the y's a second ago. Wait a second, negative 10x plus 10x, that's a 0, okay? That eliminated here. Negative 4y plus 4y, that's a 0. Okay, that's a 0 here. It eliminates here. Negative 20 minus 8, that's a negative 28. Does this make any sense at all? Okay, does this make any sense at all? What is this? What is this all about? What is this all about? Does not compute. The system is down. Doesn't make sense. Doesn't make any sense. Doesn't make any sense. Because 0 does not equal negative 28. Okay, you got 0 over here. Negative 28 is 28 units below 0. They don't equal each other. They don't equal. I don't know, make them look at an equal sign here. What I'm trying to do is like a scale. You ever see one of those scales things? These weights don't equal. These weights don't equal. But here, right, we're in balance with one another. If we're at 0 here, negative 28 isn't going to make 0 balance. Negative 28 is going to be like, oh, it's later, I guess. So it's like that. It doesn't work. It doesn't make sense. Okay, so what our answer is here, it says what happens. Okay, maybe we need to explain that. Okay, what happens? So 469, let's see here. What happened is that both variables got eliminated. I'm running out of space here. I'll get rid of this. Lim. Oh, why did I do that? I wanted to not do that. Oh, so, guys, I was just trying to deliver this lesson to you, and then it got all messy. Okay, both variables got eliminated, and a false statement. There's a false statement is produced. Okay, that is not good, my friends. Both variables got eliminated and a false statement is produced. 0 is not equal to negative 28. Are these two equations the same line? Or how can you tell? Well, wait, hold on. They're not the same line. Okay, they're not the same line because they don't have a common point of intersection, right? They're not the same line. Did I do anything wrong? I didn't do anything wrong. These are not the same line, okay? So no, these are not the same line. Okay, if they're the same line, they would have been equivalent equations. Okay, equivalent equations. If I multiply this by -2 and I get the same thing on the left side, I would have to get the same thing on the right side here. But they're not equivalent equations. Okay, because they are not equivalent equations, right? If I had taken the top one and divided it by 2, right? -8 divided by divided by 2 would have been -4, not 10. So they're not equivalent equations. So they're not the same line, right? You got to be an equivalent equation to be the same line. That's something that's kind of come up a little bit in the lesson the other day. So maybe I'll highlight that. Not the same line, right? Not the same because they're not equivalent equations. That's kind of how I'm going to justify it. Sorry if that's confusing at all here. Okay. And anyways, how can you explain the solution you got in part A? And that's what I would say is that we got it produced a false statement of equality at the end there. So what we would say is there is no solution to this system of linear equations. Okay, so I know we haven't talked about graphs too much recently. You graph this out. Technically, and we don't have time to really go over this here, but there's no solution to the system of linear equations. The lines would be something called parallel. Okay, I'm going to put that out there. You talked about parallel, maybe a little bit of middle school geometry and whatnot, maybe even some algebra type stuff here. Sometimes on the XY graph, our lines can be parallel, right? We don't know how they look, but they never touch, right? They never touch. So here, vocabulary word here, the lines would be parallel, or we would know that they are parallel. We would have proven it, okay? The lines are parallel, okay? Because there's no common solution, right? There are two lines on a graph and they never cross one another. That means they got to be parallel to one another, right? Never touching, okay? Just going the same direction, but just in different places, kind of, okay? There's no solution here. All right, question 470, a new challenge. All right, let's do it. Carefully examine the system. Remember, I'm meeting with somebody at 2:10, so I need to wrap this up very quickly. Carefully examine the system. We got that equation, that equation. With your team, propose a way to combine these equations. No, you're not with your team right now. Wish we could do this in class here. See what's going on here. I'm sure you guys would have been great in class. Anyways, we got 4x plus 3y is equal to 10. We got 9x minus 4y equal to 1. With your team, propose a way to combine these equations so you can eventually have one equation with one variable. Well, we're doing elimination today. Let's do this here. Okay, so the problem with this is here, let me use my trick. Start with the lowest term, right? Lowest number. So I got 9, -4, 4, and 3. I meant kind of like not the most negative, but like the lowest absolute value coefficient. That's 3. Let's see if I can get with that -4 to eliminate. Well, 3 times 2 is 6. 3 times 3 is 9, right? I can't get 6 and 9. Anyways, I can't get to -4 there, okay? 4, how would I get to 9 here? Times 2 is 8, times 3 is 12. It's not really going to work here, okay? So on this one here, hopefully you figured it out on your own. This one here, that's why I was trying to get you to think about this up top here. You could multiply both equations. You can just find an equivalent equation for equation number 1, okay? Here I got equation number 1 right here. Call it equation number 1. And what I can do with that is, you know what? This 3y can't get to -4y, but it could get to 12, right? I could take this one, multiply it by 4. Okay, just stay with me for a second, right? Because the idea is I want to get my 3y and the -4y. I'm going to cancel those out somehow. That's what I think. I'm not going to deal with the x's. I'm going to try to eliminate y. Well, if I multiply 3y times by 4, well, I'd end up with 16x here, but 3y times 4, more importantly, is 12y. And over here, 10 times 4 is 40. Okay, I got 12y here. Can I now, with this one right above it here, equation number 2, can now this equation number 2 get multiplied into an equivalent line where it can cancel out this one. Why? What do you think? Well, yeah, -4 times 3 is -12, and 12 minus 12 is 0. So let's just do that. We're going to have to multiply both sides by what? By 3. Look at this here. We multiplied by the 3 that was up there, and we multiply by the 4 that was down here. It's technically a -4. One of them needs to be multiplied by its opposites. Anyways, hopefully you get the point here. Multiply this by 3, and then I'll multiply this side by 3. So I get 3 over here, and I get 3 times 9x is 27x. And I get 3 times -4y is -12y. And now I can eliminate. I can totally eliminate this. Let's do this. Okay, add the left sides together, the right sides together. Let's do the right side because my mind is melting. 40 plus 3 is 43. Can imagine what your minds are like here. Oh man, 12y minus 12y, that's a 0. Okay, eliminated. We're good to go. 16x plus 27x, that's 40. Look, 43x. And again, you have your calculator out. You can do that quickly here. 43 equals 43. Well, then what's x got to be? It's obviously got to be 1, but we'll show out the work. Divide both sides by 43. 43 divided by itself, anything divided by itself is 1. And anything divided by itself is 1. And we got 1x left. So x equals 1. Let's get y so I can go get to my meeting right away with somebody. And the next minute, I'm meeting somebody during office hours. Please come to office hours, right? I'd love to see you. And let's use that in the top equation here. Okay, so 4 plus 3y equals 10. Subtract 4 from both sides. 3y equals 6, and then y is going to equal 2. Okay, so I get x equals 1 and y equals 2. So my solution is 1, 2. And we're good to go. Thank you for watching. Email me if you have any questions, right? I know it's kind of a brain drain thing here, but hey, it might come up. Who knows? You might have an elimination question on tomorrow's assessment, or is it substitution? I forget. All right. Anyways, see you guys tomorrow. Bye.